All right, hello, this is Carson again. We're going to be going over the 2024 Invitational B calculator test from 20. I already said that. Let's just begin before I can, or while I can still somewhat talk. Uh, okay. We start at the beginning with some pretty easy problems. What is the product of this number and that number? Put it in your calculator. Number 7 is the same. 1.63 plus 2.1 times 0.7696. Get 3.3. Then a lizard grows. What's the positive change in length? Well, new minus original gets you 5.43 inches. The perimeter of a square with a side of 0.75, you just multiply by 4. And then rhombus is, the area of a rhombus is still base times height, so this unknown base times that height. So you divide the area by the height to get the base. And you get 69.4. Monica wants to read A Tale of Two Cities. She reads 178 words per minute. The book is that long. How long will it take her to finish? Well, the amount of time it takes to finish is amount over, I guess, in terms of something else you might understand, it's distance over speed. So the amount of words she has to read divided by the rate at which she does it gives you the amount of minutes it takes, and then you divide by 60 to convert to hours. What is the y value of the intersection of these two y lines? Just plug them into y1 and y2, use EQ solver, and you will easily find the x intersection, and then just plug that x value back in. And you get negative 6.92. Grant Wood sold his painting, American Gothic, to the Art Institute of Chicago for $75 million. Annual appreciation rate, that was the original sales price. Well, each year that passed by multiplied it by 1.141. So to counteract that, you have to divide it by 1.41 now. And you have to do that the amount of times it's incremented. So, and that's equivalent to the amount of years that have gone by. So 2024 minus 1930. You do that, round to the nearest cent because it's a money problem, and you get $309.18. 19. This is a very simple Pythagorean theorem. C squared minus b squared equals a squared. Square root of hypotenuse squared minus height squared gets you the base. Okay, area of this right triangle given an angle and a side. Well, this side right here is equivalent to tangent of 0.62 times that side right there. And you have to multiply that side by the height and divide by 2. That's basically what we're doing. 1.83 times 1.83 tangent of 0.62 and divided by 2. Do that and you get 1.2. 26. Monica has 3 her printer ink cartridges. One is that full, and that full. If an unused ink cartridge can print 335 pages, how many pages can Monica print? Well, it's equivalent. Well, you have to add up all the ink tanks, and you get 1.7 ink tanks worth. And since a full ink tank can do 335 pages, you just multiply by 335. And it is 2 SDs because all this stuff added together has 2 SDs. And then the unused ink cartridge has 3 SDs, and when you multiply, you keep the lower number SDs. So 2 SDs, 570. Emily lives 2.8 miles from school. Driving speed limit, she gets to school in 4.8 minutes. If she's running late and drives 10 miles per hour over the speed limit, how much time does she save driving to school? Well, first off, let's figure out the speed she's normally driving, or the speed limit sign. Well, speed is distance, 2.8 miles, over time, converted to hours, is 4.8 over 60. And that will get you a speed of 35 miles per hour. Once you have that, you know that 10 miles per hour over is 45, so the amount of time it takes is distance over speed. Distance over speed converted to gets you the time in hours, convert to seconds. Then you do the same thing for going 10 miles per hour over to find the amount of time she saves. And if you do that, you get 64.0 seconds. Okay, a school bought 6 dozen Krispy Kreme donuts at $13 per dozen. Sold them at the school for a fundraiser, raised $50 even though they ate 1 in 9 donuts. What is the increase in donuts cost? Well, first off, let's figure out how many donuts they actually sold. So 6 dozen, so 6 times 12, and they only sold 8 out of 9 of them because they ate a ninth of them. So 64 donuts is the amount they had. So, and they raised $50. So the basically when they say raised here, they mean profit. Basically, how much they made profit. So you have to. So the revenue they made is equivalent to the original cost of the donuts. So $13 times 6 plus the $50 profit, and that's divided by 64 donuts that are sold. And then the price they bought them at was 13 over 12 because $13 per dozen. 13 over $12 per donut. And the equation for a percent increase is new minus original over original. So you divide it by that 13.2 again and multiply by 100 to make it a percent. 29. Okay, you're given a cone. Volume of a cone is this base times this height over 3. So this base is this unknown over 2, which is your radius, squared times pi. That's your base. And then you multiply it by your height, divide by 3, and that value has to be equal to 20,900. Put that in EQ solver, and you get 46.6. 30, the cylinder. Okay, lateral surface area. Well, the lateral surface area is the circumference of your base times your height. So 0.93 pi is your circumference, diameter times pi, and then multiplied by the height of 1.21. 36, a drone flies at 400 feet elevation and 95 miles per hour. It is directly overhead, and they fire a rocket that travels at 230 miles per hour. How far does the rocket travel to intercept the drone? Well, you gotta figure out the vertical speed at which it travels, which can be equated by drawing a triangle. I'm gonna wait. All right, so the triangle looks like this. The rocket's traveling at 230 miles per hour, and the drone is flying horizontally at 95 miles per hour. So you have a right triangle. You have one of the bases, you have the hypotenuse, so use Pythagorean theorem to figure out the vertical speed. It's going to be this right here. And then you multiply by 22 over 15 to convert from miles per hour to feet per second. That's a ratio you should know. And then if you divide distance by speed, you'll get the amount of time it takes, which I believe will be around like 1.3 seconds or so. Yeah, that sounds about right. And then now you have to multiply your time by your speed again to find out how far it travels. 230 miles per hour converted to feet per second times seconds. What is the length of the line segment defined by the intersection of these two curves? Well, you got to plug them into y1 and y2. You got to find both intersections, the negative one and the positive one. And then once you have that, you have to use Pythagorean theorem for the for like the distance. So your difference in y. So I probably should have wrote this down here. I'll write it right now. Square root of y2 minus y1 squared plus x2 minus x1 squared. You may have learned that in algebra. And if you do that, you get a value of 9.01. Okay, 38. How many minutes after that do the minute and hour hands of the clock line up? Just use our clock program we have, plug in hours, plug in minutes, and it'll give you the time of the first intersection. So 39, this is another one that we have an easy program for. No point in using the semi-perimeter formula to try and find this thing. Just use triangle, circrad, and then plug in all three sides and it'll give you the inscribed radius. Okay, 40, you have to be a bit more creative. To find AB, you need to have knowledge of some aspects. Specifically, you need this angle X right here. And then once you do that, you can use our side to figure out this angle right here. And then once you have that value, you can use AAS for AB. Let me check what the value you would get was, just so I can verify this to you, or that you're doing it correct if you're following along. So you get an angle of around 78.26. Should be about the angle you get. And then you can either use law of sines to figure out that angle or use our AAS program to solve for AB. You do that, you get 379, you move on. 46, this is a scale problem. Pizzas have the same thickness regardless of size. If a 14-inch pizza feeds 3 people, a sized pizza feeds 100 people. Well, since its thickness is the same, the volume is only based on by the radius / diameter squared, which that's what this represents, the radius or diameter. I don't actually remember which one, but it doesn't matter. In any case, since you're multiplying by r squared to get the area, to figure out the new length, you have to take the square root of the multiplied difference in the amount of people you have to serve. So square root of 100 divided by 3, multiplied by 14, you get 80.8 inches. A very, very large pizza. All right. Okay, 47 is 2,002 miles traveling from Texas to Massachusetts. Olivia's daily driving distance the first 3 days were 310, 250, and 300 miles, and estimate the total number of days for the trip. Well, the way that we found that they want you to input this data is they want you to input day and then the total distance traveled. So after 1 day, you traveled 310 miles. After 2 days, you traveled a combined 310 plus 250. And after 3 days, you traveled the entire distance combined. So stat edit those values, use linear regression, and use EQ solver to figure out when y1 is equal to 2002. You'll get like 7.14, I believe. And then you have to round up because after 1 day, it doesn't matter. After the day is over, it doesn't matter if you're really close. You still got to go into another day to finish off your trip. So you have to round up no matter what. 48, EQ solver, plug it in. Very easy. You never miss that kind of problem. Okay, cube with cylindrical cavity. They give you the surface area, so let's find the surface area. Well, it's a cube, so you have 6 squares on all sides, so x squared times 6 would be your surface area if it was just a cube. However, there are 2 circles that have been taken out of the surface area, as you can see here. So you have to subtract the area of those circles, done here, multiply by 2 because there's 2 of them. And then you also have to add back a new surface area, which is the inside of this thing right here, which is a lateral surface area of a cylinder. And to find the lateral surface area of a cylinder, you take the circumference multiplied by the distance, or by the height, and that will get you the lateral surface area of your cone, as seen right here. And all of that has to be equal to 0.0497. Do that, you get an x value of 0.0818. 50, half cylindrical prism and isosceles triangle. Prism, well, and you're given that the volumes are equal, so you just gotta calculate the volumes for both of them. So 7.24 squared times pi over 2 is going to get you the area of the semicircle. You know, r squared times pi and divide by 2 because it's a semicircle. Then you multiply by this length to get the volume. And then that has to be equal to the area of this triangle. So 7.24 times 2 is the base, times your unknown height, x, and divide by 2, because it's a triangle, gets you the area. And then that's also multiplied by 22.7. You can completely ignore this. They don't actually have to give you this value right here. So, but in this case, I just put it in anyway. Regardless of what you do, you get a value of 11.4. Okay, what is the slope of the curve? This giant equation, x equals 8. Well, you just plug this equation into y1 and find the derivative at x equals 8. So math, scroll up, deriv, d over dx of alpha f4 y1 at x equals x. And you get your answer of 144. Just make sure you're in radians, like the problem says. Okay, a 100-pound log decays proportionally to the amount of remaining mass. If a 10 lb of the log decays in 150 days, how much longer would it take for 90 pounds to be decayed? When it says it's proportional to the remaining mass, or basically when something decays proportionally to the value you're measuring, this basically means it's an exponential problem. So that means is that it's decaying exponentially. So like 0.9 power to x, kind of in this case. So you have to figure out the amount of times 0.9 is being multiplied to get to 0.1, or I guess I should tell you how you got 0.9. 10 pounds of the log decayed, so that means 90% was left. So it was multiplied by 0.9. And you gotta figure out how many times it has to be multiplied by 0.9 to get to 0.1. So you're looking for how much longer it would take. You have to subtract 1 because otherwise it would account for the original 150 days. Then once you have the amount of times it's been multiplied, you have to multiply by how long it takes to multiply. So 150 over 365.25 to convert to years, and you get 8.56. Solve for positive g if the determinant of that is equal to 35. Well, you can actually just put that into EQ Solver, math, EQ Solver. You go to matrix and then math determinant, of course. And then you can also just do alpha F3 and make your own matrix. And then just plug in all the values, set it equal to 35, and you get a G value of 1.08. 59, what is the hatched area of this thing? Well, we have Oxor program. Just make sure your y2 is equal to 0. Plug this into y1. Your lower bound is 0, your upper bound is pi, and your line of revolution is not relevant to this question. So then you just find the area under the curve, which is 3.14, which is, I'm pretty sure it's just pi, which is very interesting. 60 identical circles. You got to figure out this length right here. Well, and you're given the hatched area. Well, this is, as you can hopefully see by the triangle I drew out, that this side of the circle, right, or the hatched area, represents half of the entire thing. This is equivalent to the segment of a circle, like that, minus by the triangle that would be formed from that angle. Basically, we need to find out this angle. And once we have that, we can solve the problem. So we have the area of our segment, which is going to be 6.74 squared times pi times the angle over the entire 360 degrees of your circle. Like 360, an x value of 360 degrees would just be the entire circle. So you multiply your unknown angle and divide it by your entirety of 360. Then you have to subtract it by the triangle area, which is going to be side squared, sine of this angle, over 2. So 6.74 squared over 2 times sine of x, and it's equal to half of the hatched area. So 17.5 over 2. Then once you have your angle of around 80 or something, maybe it was like 78, I remember, you now have to find out basically this line right here. And to do that, you just do definition of cosine. Cosine of x over 2 times your radius, and then you multiply by 2 because it's dual-sided. Do all that, you get 10.5. 61, largest recorded hole-in-one was made by Mike Green at Green Valley Ranch Golf Club in 2002, distance of 517 yards. Golf cup is that long in diameter. What is the maximum angular dimension, or what is the ball must travel in? I can't say I'm 100% sure why this works. I believe it has something to do with the definition of angular dimension. In any case, I've never seen a problem like this before, and I doubt I ever will again. So what you do is basically you're figuring out the proportion of the distance of the golf cup to the entire hole. So 4.25 over 517 yards, converted to feet, converted to inches. And then you take sine inverse of that, make sure you're in degrees, and you get 1.31 times 10 power to negative 2 degrees. Okay, a zeptosecond is 10 power to negative 21 seconds. What is this number raised to that power? Well, this is going to be a less than 1 problem, so it's underflow. We'll use our over function program. So your base is going to be 10 power to negative 21, and your exponent is going to be this power right here. Do that, you get 1.00 times 10 power to negative 1371741. And then 63, Zelda stands 15 feet away from a 25-foot wall. She tosses a ball to Xavier, who stands on top of the wall. What should the release angle be relative to the ground if the ball has no vertical component of velocity when it is caught? Well, if it has no vertical velocity, that means when it's caught, it's already reached its max height. So we have a kinematics program for this. Kine, 2D, and then X, Y, Z. This Z is max height for some reason. So it's gone 15 feet. It's gone up 25 feet, and the max height is still 25. To do that, and you get an angle of 73.3 degrees. 64, hatched area is that. What's the side of your square? Well, first off, we got to figure out what area what percent of the entire square area this hatched area encompasses. So for that, we can assume side is equal to 1. So the entire area of the square makes up 1. 1 times 1. And then you can subtract all these triangles. So 0.5 times 1 over 2. 0.5 times 0.5 over 2. And then 0.5 times 1 over 2. Subtract that, and you get that this hatched area makes up 37.5% of the entire square. So once you have that, you divide 0.375 that we got by 1 to find out the entire, and then you multiply it by the hatched area to figure out the area of the entire square. And then once you have that, you take the square root of the area and you get your side. Okay, almost done. 65. Circle an equilateral triangle. Find this hatched area. Well, this is a triangle inscribed in a circle. So since it's an equilateral triangle, let's just figure out the side right here. If I draw a triangle right here, you can see that this side, wow, very nice triangle. But this side is basically, this is hypotenuse, so this side is, no, this is not 60 degrees. Never mind, what am I doing? Excuse me for a second. This is your right angle. This is 60 degrees because the entire triangle, if drawn out, The entire triangle is drawn out. These would be segments of 120 degrees because the entire circle is 360 degrees. This angle is half of that at 60. Sine of 60 times your hypotenuse, multiply by 2, you get your x value. I believe it was like 1.5 or something. And then once you have that, you do the area of your circle, radius squared times pi, minus the area of your equilateral triangle, which the formula for that is side squared times square root of 3 over 4. Do that, you get 1.41 as your hatched area. Okay, that's the entire test. Hope you enjoyed. If you have any questions or need more specifics, either ask me in person or if I'm not there by the time you watch this video, leave a comment and I'll hopefully still be responding. Anyway, see you later.